Contents of lecture number 12 are finding unknown terms of a quadratic equation if its roots satisfy a given relation, that is, we would be given some relation regarding the roots and we will have to find out the unknown term within the quadratic equation. And the second one is if both sum and products of the roots are equal to a given number. Symmetric functions of the roots of a quadratic equation. Now let's start with finding the unknown terms of a quadratic equation if its roots satisfy a given relation. Exercise 2.3, question number 3, find k. If the sum of the squares of roots of the equation 4kx square plus 3kx minus 8 is equal to 0 is 2. The equation is given to us. We will start the solution with the comparison, and after comparison we get a is equal to 4k, b is equal to 3k and c is equal to minus 8. Now let alpha beta be the roots of the given equation, then sum of roots be alpha plus beta, and from the formula point of view it is minus b by a. So putting the values of b and a we get minus 3k divided by 4k. K will be cancelled out with 4 with k and we will get sum of the roots, that is alpha plus beta is equal to minus 3 by 4. Likewise we will find out the product of roots, that is alpha into beta, and from the formula point of view it is c by a. So putting the values of c and a we get minus 8 divided by 4k. Minus 8 divided by 4 is equal to minus 2. So it will be minus 2 by k. So alpha beta is equal to minus 2 by k, and that of alpha plus beta is equal to minus 3 by 4. Now we will utilize the condition given to us. According to the given condition, sum of squares of roots is equal to 2. Now one root is alpha and the other one is beta. Their squares be alpha square and beta squares, and then their sum of the squares be alpha square plus beta square. So the given condition can be represented symbolically as alpha square plus beta square is equal to 2. Now alpha square plus beta square is equal to 2. That is alpha square plus beta square is equal to 2. Now since we know that a plus b whole square is equal to a square plus b square plus 2ab, so by using this formula as alpha plus beta whole square is equal to alpha square plus beta square plus 2 alpha beta, since we are going to find out the value of this alpha square plus beta square, we will have to shift this 2 alpha beta towards the other side, and the formula will become alpha plus beta whole square is equal to alpha square plus beta square. So we have replaced alpha square plus beta square by this alpha plus beta whole square minus 2 alpha beta. Since alpha square plus beta square was equal to 2, so is the relation which is equivalent to alpha square plus beta square. So we have replaced alpha square plus beta square by this relation, that is alpha plus beta whole square minus 2 alpha beta. Now since we have found the values of alpha plus beta and alpha beta as sum of roots and the products of roots respectively, so we will use those values which we just found as alpha plus beta and alpha beta. So putting alpha plus beta is equal to minus 3 by 4 and putting alpha beta equal to minus 2 by k, we just get 9 by 16 plus 4 divided by k is equal to 2. While adding the two fractions we just get 9k plus 64 whole divided by 16k is equal to 2. Multiplying 16k on both sides we get 9k plus 64 is equal to 32k. While shifting 32k towards the left hand side we just get minus 23k is equal to minus 64. This minus on the left hand side will cancel out the minus on the right hand side, so we will get k is equal to 64 divided by 23. So the value of k is 64 divided by 23. Question number 5 is the roots of the equation x square minus 7x plus 3m minus 5 is equal to 0. Now the unknown in this equation is m. So we are going to find out the value of m. That is x square minus 7x plus 3m minus 5 is equal to 0 has an unknown term, that is m, and we are going to find out the value of m. For this, the condition or the relation given to us is 3 alpha plus 2 beta is equal to 4. So we will use this particular relation to find out the value of m. Now let's start with the comparison. We have a is equal to 1, b is equal to minus 7 and c is equal to 3m minus 5. Let alpha beta be the roots of the given quadratic equation. Then sum of roots, that is alpha plus beta, will be minus b by a, and while putting the values of b and a we just get alpha plus beta is equal to 7. So it is our equation number 1. Now we will find out the product of roots. Since we know that product of roots in terms of formula is c by a, so the product of root, while putting the values of c and a from the given quadratic equation, we just get alpha beta is equal to 3m minus 5. Now 3m minus 5 is the part of this equation, that is alpha beta is equal to 3m minus 5. But to find out the value of m from this equation, we must have the values of alpha and beta first. So while putting the values of alpha and beta, we will easily find out the value of m. But for finding the value of m, we will have to first find out the values of alpha and beta, and for this we will use the given relation. According to the given condition, we have 3 alpha plus 2 beta is equal to 4. This is the relation which was given to us in the sum, in the statement of the sum. So we are having the two simultaneous linear equations. One is alpha plus beta is equal to 7 and the other one is 3 alpha plus 2 beta is equal to 4. By using these two equations, we will find out the values of alpha and beta. So multiplying equation number 1 by 2, we will multiply this equation, that is alpha plus beta is equal to 7 by 2. It will become 2 into alpha plus beta is equal to 2 into 7, and after multiplying we will get 2 alpha plus 2 beta is equal to 14. Now we have the two equations, equation number 3 and equation number 4. We will use these two equations, or we will subtract these two equations to find out the value of alpha. So subtracting equation number 4 from equation number 3, we get alpha is equal to minus 10. Now putting alpha is equal to minus 10 in equation number 1. Equation number 1 was alpha plus beta is equal to 7. So replacing alpha by minus 10 in that particular equation, we will be having minus 10 plus beta is equal to 7. Shifting 10 towards the other side, we will get beta is equal to 17. Now we have the values of alpha and beta which we were supposed to find out in order to find out the value of m, which was part of equation number 2, that is containing the product of roots. So putting the values of alpha and beta, we get minus 10 into 17 is equal to 3m minus 5. It will be minus 170 is equal to 3m minus 5. Shifting 5 towards the other side, we just get minus 165 is equal to 3m. Dividing both sides by 3, we get m is equal to minus 55. So the value of m is minus 55.